present problem considered for this video is the GATE problem of 2007 in the area of electromagnetics and the subtopic of Poynting vector. First we'll read out the problem and then try to give the solution to this problem. Here the H field in amperes per meter of a plane wave propagating in free space is given by H. The magnetic field is given here, which has the components of X and Y directions. The time average power flow density in watts is, all these four options are given and you have to find out which is the appropriate option. Now we'll try to see from this problem that here the H field part is given. What we observe from their H field, that there is a X component of the field and there is a Y component of the field. Both the components are there in the H field and the propagation is in the direction of Z, because they indicate here this is sine omega t minus beta Z, omega t minus Z. This is propagation in the plus Z direction. Now if we try to see the H field, as I said, there are two components X and Y, and the propagation is in the Z direction. Now we have to find out the time average power flow density in watts. So average flow in a Poynting vector, we have two basic parameters. One is the power flow per unit area. That's a complex power flow, that is P equals to E cross H. P equals to E cross H. This is the complex power. And if we want to really find the real power, then we have to have this relation, time average power flow. This is half real part of E, the electric field, cross the magnetic field and its complex conjugate. So you have to see that that to get a real power, we have to find the value for E and H and their complex conjugate. And also for the plane waves, we know the E is related to, in a free space, E by H is eta, or E equals to eta naught H. So by looking into the electric field, the magnetic field part which is given here, we observe here this is a magnetic field part, and this part cos omega t minus beta Z, here is sin omega t minus beta Z. We will try to make it identical so that it simplifies our problem further. So if I try to solve sin of omega t minus beta Z plus pi 2, this could be written as cos of minus omega t plus beta Z, and cos of minus theta is cos theta, so this also comes to be cos omega t minus beta Z. So what happens is both the cos terms here are same in X and Y directions, and instead of writing a cos term, we can also write the term like a complex exponential form. That means we have rewritten the H, X, pi root 3 over eta naught plus Y, pi over eta naught, and e to the power j omega t minus beta Z. This is a complex form of sinusoidal variation indicating the plus Z direction as the direction of propagation. Now by knowing this, we'll apply this relation that P average equals to half real part of E cross H. This is the value of E. I have written E, H, E, that is eta into H. This is the E and this is the H part. Now what we observe from here is the first part and the second part here, these two parts, when we try to find the complex conjugate of H, then this term will become the complex conjugate. That means having the imaginary part to be negative, and similarly here the complex part of here E j omega t minus beta z. When I take a complex cross multiplication here, these terms here, one having j omega t minus beta z and the other e to the power minus j omega t minus z beta z, because of E H complex conjugate, they cancel out. So we are left with only this part, and this part actually the x components and y components, they are in quadrature, and if I take a cross product of these two terms here, we can very easily write here, since they are in quadrature, I can write a plus jb into a minus jb could be a square plus b square. So this is the way I have written this, and this turns out to be 50 by eta naught. This is 50 by eta naught, and this is the right kind of answer for this. That's the right option for this particular problem. Thank you.